For as long as we've been around, humanity has looked up at the stars, looked at the world around us, and asked one simple but really profound question.
How does all of this work? I mean, you've got this seemingly chaotic dance of the planets, the way light bends, the very fabric of space and time. For centuries, it was all just this grand, beautiful mystery.
But here's the amazing part. What we found was that this chaos, well, it wasn't really chaos at all. Beneath all that complexity, there was a hidden order, an elegant, predictable structure just sitting there waiting for us to understand it.
And the key, the universal language that let us finally read that hidden structure, was mathematics.
And suddenly, everything started to click. With equations and models, you had giants like Isaac Newton, who could describe the precise motion of planets. Albert Einstein could explain the very nature of space and time. Mathematics took this huge, overwhelming mystery and transformed it into something we could actually grasp, predict, and explore.
But here's the thing. Every single one of these world-changing discoveries, they all started in the exact same way. It wasn't some brilliant answer just popping into someone's head. Nope. It all began with a clearly defined problem. This became the classic path for discovery, especially in physics. You start with a problem, right? Why do planets move the way they do? Then you apply the tools of mathematics, and that, in turn, leads you to a new level of understanding. A problem sets the stage. It defines what you know, and more importantly, what you're trying to figure out. So, fast forward to today, we're now exploring a completely new kind of universe. And this one isn't made of stars and galaxies. It's a universe made entirely of data, a totally endless, expanding ocean of information that we ourselves are creating every single second. Just think about it for a second. The constant stream of data from global financial markets, the incredibly complex web of connections on social networks, the terabytes of information pouring out of scientific experiments, all of it creates this huge ocean of data, and hidden inside are patterns just waiting to be discovered. Which brings up a great question. If this whole data universe is so new, where did the science for exploring it, data science, actually come from? A lot of people just assume data science is a product of the computer age, but its true foundation, it's much, much older. And yep, you guessed it, it's mathematics, all over again. Long before the first computer was even a dream, mathematicians were already developing the tools to find patterns and manage uncertainty in data. This field, statistics, is the absolute bedrock of modern data science. It gives us the core methods for analysis and interpretation that we still rely on today.
And this is what makes the connection so clear. The fundamental question of physics was, how does the universe work? The fundamental question of data science is, what patterns exist inside data? The scale might be different, but that intellectual quest is remarkably similar.
This table really breaks down the analogy. Just look at how the core concepts translate directly. We've basically traded the cosmic scale for the data universe. So instead of using the laws of nature to understand how planets move, we're now using statistical models to find patterns in data. The fundamental approach, the way of thinking, it's exactly the same. So this brings us to machine learning. It's essentially the modern, super-powered application of these mathematical principles. We're using powerful computers to run statistical models that can learn directly from data and even make predictions about the future, all without being explicitly programmed for every little thing. And this brings us right back full circle. Remember that path to discovery in physics? A problem followed by mathematics leading to understanding? Well, the data science path mirrors it almost perfectly. It starts with a problem, we gather the data, we apply a mathematical model, and we arrive at an insight. It's the same fundamental journey. So the very same kind of mathematical thinking that allowed us to map the stars now allows us to find hidden meaning in massive data sets. It truly is a different universe, but it's the same mathematics. Which leaves us with a pretty fascinating final thought. From the motion of galaxies to the patterns hidden in our own digital world, mathematics gives us the tools to find the structure in it all. The only question left is, what patterns will we discover next?